Well, all right. Can you hear me okay? You hear me okay? I'm going to angle you a little bit.
Yeah, I can hear you.
And because in basketball you cannot touch the line or something like that. Yeah.
Now I should learn how to zoom that thing. I got to I'll practice that after. All right, so.
I'm the best basketball player in the world. Really? I'm terrible. But yeah. 1 hour and 40 minutes.
So, does anybody have any questions before we start?
No.
So when is your, well, this is kind of your second homework. The quiz we'll have a little leeway with on the math quiz, but when's your first test due?
Sunday.
Sunday, this Sunday, not a week from now, but this Sunday. So your test is already coming up. So remember, you need to be on and hopefully working those problems. This is not a Sunday to Sunday deal. When is your homework due? Saturday night. Saturday night.
I need to get it up to that.
So your homework needs to get done by Saturday night. Now here's the deal with the homework. If you guys blow it off, I don't think it's a good idea to do, but you'll still have full access to it at 80% credit. Okay? I almost hate to say that, but 80% is a good, I mean, a 20% ding on it is pretty good, especially for gimme points. So I don't recommend doing that very often. So get it done by Saturday night. If you go to it Sunday, then you'll still have full access like you did before, but the system's already built in with a 20% late fee if you start it on Sunday. And it's really just too much material to try to get in and all in one day between taking the test and doing all the other stuff. So that's why I've done a little staggering to Saturday. All right, any questions there? All right. So we're going to wrap up chapter 2 today. And let's see, that thing looks like he isn't on yet. I'm going to check my volume, make sure that's working all right. So we did the production possibilities frontier with Tom and Jen on the island. And I want to go over another example with that today. That's in a little bit different way, so we kind of hit you in a different way. And think about beer and pizza. It's usually kind of one of my ones I like to do. So we're gonna start with some beer and pizza today. So we've got the quantity of beer and the quantity of pizza. And so the production possibilities frontier is a economic model that shows the maximum combination of two goods an economy can produce given its available resources and technology. So the production possibilities, did I give you this definition last time? I can't remember. We just went over it on the thing, but I don't think I actually wrote it down in your notes, right?
No.
All right, so the production possibilities frontier, the PPF, which is what we did with Tom and Jen, is it shows the maximum combination of two goods an economy can produce, shows the maximum combination of two goods an economy can produce given its available resources and technology. The maximum combination of two goods an economy can produce given its available resources and technology. All right. That's what we did with Tom and Jen. That's what we're going to do here. So in our economy, we're going to say, given all of our available resources and technology, what are the maximum combinations of beer and pizza that our economy can produce? And if we have 20 beers, we cannot have any pizza. So we got our schedule goggles on, remember now. If we give up a beer, we can get a pizza. So 19 and 1 is another possible combination. 16 and 2 is another possible combination. 12 and 3 is another possible combination. 7 and 4 is another possible combination. And then finally, a sad day, if we want to have 5 pizzas, that means we got no beer. Okay? Can you hear me okay, Hunzi? Can you hear me? You can give me a thumbs up if you want. Thumbs up?
Yeah.
Okay. Great. So now, put on your graphing goggles. I want everybody, I'm going to walk around the room and see how you're doing, but I want you to graph this. And I want you to put beer on the vertical axis and pizza on the horizontal axis. And I want you to be kind of careful with your graph. We won't always be this careful in class, trust me, but this time I want you to scale this thing. So kind of go, you know, maybe you can do big spacing down below since it's only 5, like 1, 2, 3, 4, 5. And then on the horizontal axis, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then graph it out. I'll kind of walk around class. Hunzi, I'm going to want to see your paper too when I get to it, so go ahead and graph this out. If you have any questions, of course, raise your hand. I'll help you out. Just kind of talking these things. Yeah. So just once you get all those dashes, yeah, then just but don't assume that you just kind of let the points plot themselves. That's why I wanted to be careful. Can you see that okay, Hunzi? Okay, good. Am I pronouncing your name right? Double thumbs up. Ooh, wow. Okay, it looked like most of you are getting the right idea here. So 20 and 0, 19. 16 or 12 and 3, 4, 5 and 0. Okay. Let me see your paper, Hunzi. I didn't get the chance to see yours. Okay, good. Yep, got the right idea on. All right. So if you look at your points really carefully and you actually spaced your hash marks pretty good, not perfectly, what do you notice about the shape of the production possibilities frontier? It's curved, isn't it, right? It kind of bows outward. It's not a straight line like we had with Tom and Jen. It bows outward, which is a little bit different than what we did with Tom and Jen. And in fact, this production possibilities frontier being bowed out is more realistic to the real world. And we'll kind of explain, kind of think of why that might be the case. And to think about that a little further, I want to think about opportunity cost. So opportunity cost is one of the top 3 economic principles of all time. Opportunity cost. And opportunity cost is the cost of something, measured in terms of what was given up. To get an additional unit of a good. The cost of something measured in terms of what's given up to get an additional unit of a good. So of course we're totally fixed on dollars of things, right? Oh, well, what did that cost you? Well, it cost me, $5 or something along those lines. So this time we're thinking of it in terms of what was given up in pizza and beer. And in fact, the market system does this for us. We just don't usually think about it this way. So give me a good, any good. Let's just pick something on the shelves of a retail store like Walmart. Give me a good, any good. What I hear? Ramen and shoes. So if I take the price of ramen and divide it by the price of shoes. All right, so ramen, we better buy a multi-pack to get up into something even like $1.29, right? If we had a 12-pack. What's ramen? Who's been shopping for ramen lately? This is the start of school, so what's ramen running for whatever you paid for a multi-pack of ramen or whatever? That's cool. Yeah, just tell me what you bought and what the price was. $4. So give me, and let's just be kind of cutesy with this. Let's say it was, what, $3.89 or something? Okay, I just want to be a little bit cutesy so that we get realistic here. So this is 3.89. And Aiden, what kind of shoes? Shoes, of course, are across the board. What kind of shoes came to mind for you? What were you thinking?
Nikes.
Huh?
Nikes.
Nikes. What level? What price?
$100.
$100. Let's be a little more cutesy with that. What were they on sale for? What did you actually pay? 96. And what change? 96.99. There we go. All right. So this is what we're used to saying of, oh, what's the cost of the ramen? What's the price? But really, in econ class, we're going to think about the price of the ramen. The cost of the ramen was something a lot less because the company had to make a profit on it, right? If we start, we'll get into that into the later chapters. But for this calculation, we can do something special. I'm going to use some weird notation here on you. So this is really $3.89 per ramen, right? And this is $96 per shoe. All right, so I'm kind of using weird notation. Of course, we know we usually put the dollar sign over here, and we might say per shoe or something, per shoe, dollar sign per shoe or something. So I'm going to write it a little bit like that. And if I do the math here, which I've got my calculator, 389 divided by 96.99 equals 0.0401. 0.0401. So this is called the relative price. One price relative to the other. And what is this the price of? If I do, back to math class, fraction divided by a fraction, how do I solve for that? Multiply by the reciprocal, right? Take the denominator, the downstairs guy, flip it over, and multiply it times the numerator, right? So it's S per dollar, right? I'm just flipping that sucker over. The dollars cancel, and I'm left with 0.04 shoes per ramen. Is that the price, the real price, is what economists you're going to see in the upcoming chapters. Is that the real price of ramen, or is it the price of shoes, 0.04? Is that the price of a ramen or the price of shoes? 0.04. Price of shoes, right here. Ramen. Both. Let's go back to the 389 when we were in the dollar world. Now, what I've done, by the way, is kind of cool. I've dropped the veil of the economy. Sometimes, I can't remember what economist came up with this, but they said the pricing system is actually the veil for the economy. The real economy lies behind the curtain. And so what we did is we just kind of peeked through the curtain like this. What's going on in here? There's real stuff going on. Right? The prices kind of mask that, and this is what I mean by that, because economics is about exchange. Remember how we spent so much time talking about how voluntary exchange is so important? Here's the trade that was going on right here. 0.04 shoes per ramen. Does that sound like the price of ramen or the price of shoes? Price of shoes? How much does a piece of ramen, or what do you got, a 12-pack or 6-pack at $4? 12-pack. What's a 12-pack of ramen running you? Well, it's running me about 0.04 of a shoe. So is 0.04 the price of shoes or the price of ramen? Price of ramen, right? It's how many shoes were given up to buy the ramen. In other words, Aiden would be giving up 0.04 of a shoe. That would be the fraction of a shoe if we could carve that shoe up into fractions, and they allowed us to do that, so we want to run up to Walmart. Well, how much is that ramen? Well, it's going to cost you 0.04. Okay, well, let me give you a shoelace here. Will that work? Right? So that's literally what you're doing, though, in terms of the goods that you're giving up. The goods that you're giving up to get other goods. That's the trade that's going on. If we didn't have money in the economy, we would have to find, if we only had shoes, if Aiden wanted to eat, he'd have to find people that are willing to accept shoes on trade. And then furthermore, instead of being able to buy one 12-pack, in reality, he'd probably have to cough up, he'd have to buy a whole bunch of ramen. Luckily, that has a shelf life of, what, a million years or something, so they'll probably eventually use it up. So if we flip this equation and look at the price of shoes divided by the price of ramen, we get 96.99 divided by 3.89 equals 24.93. 24.93 ramens for every shoe. Hey, what did those shoes cost you? Oh, it cost me about 24.93 12 packs of ramens. All right, cool. That's pretty good. Good price. Must have been on sale or something. Right? So we start thinking about the goods that we're giving up to get other things. That's the idea of opportunity cost. What did I give up to get something else? Those of you, I know there's a handful of you that either had personal finance with me or are in it right now. This is a big ocean there, right? When we think about dollars, if I spend my money on this, that means I did not spend my money on this. We never do this in personal finance class. But this tells you exactly how much you gave up of the other good. You gave up 0.04 of a shoe to get that 12-pack of ramen. Yes? The relative price. So this is the, whoa, what happened here? We must be bouncing around too much. The light. The light has shined. This is how important this is, right? This is like a moment here. All right. So the 24.93, is that the relative price of shoes, or is it the price of ramen?
No.
Shoes. It's always the one downstairs. Think about it. 24 12-packs of ramen will buy me one shoe. Right? So the thing that's expressed per unit, that's what it's the price of. So it's actually the thing that is upstairs in this expression. But we can go back and forth with it. But the main thing is thinking of this quantity for quantity trade that's going on. Okay, so back to this problem here. What is the opportunity cost? The opportunity cost of the first pizza is What did it cost me? What did the first pizza cost me?
Beer.
1 beer, right? So the opportunity cost of the first pizza was 1 beer. The opportunity cost of the second pizza is 4 beers. Does everybody agree with that? I hope not, because it's wrong. Look at the language carefully. Look at the language carefully. Even though I got a little ditto, 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 ditto. The opportunity cost of the second pizza is, Ashley? 3. Why 3? Okay. So if I'm looking for the cost of the second beer, implicitly, how many do I already have? 1. Because I want the second, the 1 extra one, right? And so that means that I was living here in this world with enjoying 19 beers and 1 pizza, and I'm like, what would be the cost of the second one? Well, you'd have to give up 3. Good. So the opportunity cost of the second pizza is 3 beers. The opportunity cost of the third pizza is
4.
4. All right. So now as we start to look at this schedule that you guys will see on many homework problems, you can start to break this down a little bit differently with the trade-offs. And you might do this on your paper now to think, if I go from 0 to 1, that's 1 more pizza, but it's going to cost me 3 beers. 1 more, the second one, it's still 1, but this time it's going to, oops, I screwed up. This is 1. From 20 to 19 is 1, 1 for 1, 1 for 3, and now as you guys correctly identified, 1 for 4. 1 for 5, 1 for 7. So we're going to write all those out next here. So the opportunity cost of the third pizza is the 4 beers. The opportunity cost of the fourth pizza is, what was it, 5? And finally, the opportunity cost of the fifth pizza is 7. Okay, if you're a little lost yet, we're still going to do some more of this, so you're not too late. You're not far gone. Okay. What is the opportunity cost? We went back and forward with ramen and shoes here. What is the opportunity cost of the first beer? Opportunity cost of the first beer. How many? 19. 19. Other people. A third of a pizza? Okay. What else? Anybody else?
7.
7. So we got 7, 19, and a third, I think I heard. Right? So we got some interesting answers. 1.
Don't you gain with it?
So let's start with that same logic. If I'm looking for the cost of the first pizza, the first beer, implicitly, how many do I have currently? 0. So where am I on this graph? So 1, 0, right? So I'm looking for the cost of going from here to here, right? On that part, or I'm sitting over here, right? If I put my schedule goggles on, where am I living, so to speak? Down at the very bottom, right? So, given this limited information, the first beer lives in this interval somewhere, if you know, right? Between 0 and 7. The first one is like right there. And so when we have a schedule of information like this, sometimes we have to work with that limited data. And so what I can do here is say, I know that over this interval, 7 beers can be traded for 1 pizza. I'm not interested in the opportunity cost of the first 7 beers. I'm interested in the first beer. How many beers is that? The first one is just 1. how can we alter this equation now with our equation goggles on? How can I alter this so that I get a 1 here? Divide by 7 magically gets me a 1 over here. But my math rules tell me what I do to one side of the equation, I got to do to the other side of the equation to keep things fair. And boom, 1 equals 1/7 of a pizza. So the opportunity cost of the first beer is 1/7 of a pizza. All right, if you're still a little froggy on that, we're going to do another one. How about the opportunity cost of the 9th beer? Opportunity cost of the 9th beer. Opportunity cost of the 9th beer.
Yeah.
Got a lot of information up there to digest, don't we? The 9th beer. Now, let's go back to our process here. If I'm looking for the cost of the 9th beer, how many do I currently have? 8. So think about where I'm at on my schedule. And I'm looking for the cost of the 9th. 1/5. Good. So, again, we don't have exact information in between here, but we do know that the 9th one lives between 7 and 12, if you will. Over this interval, I know that 5 beers can be exchanged for 1 pizza. I don't want the opportunity cost of the next 5 beers. I just want 1, specifically the 9th. Divide by 5. What I do to one side of the equation, I do to the other. The opportunity cost of 1 beer in this interval is 1/5 of a pizza. 1/5. What is the opportunity cost of the 15th pizza? All right, now we're starting to, or beer, sorry. The 15th beer, 1/4, right? So again, just to make sure we're getting everything, find the 15th beer is right here. We don't have information on that. I know that I can trade 4 beers for 1 pizza. I don't want the cost of 4 beers. I want the cost of 1 beer, specifically the 15th, if I had enough information. So the best that we can do is approximate. 4 divided by 4 equals 1 beer. What I do to one side of the equation, I got to do the other. So the opportunity cost of the 15th beer is 1/4 of a pizza. Okay, Tia, do you have a question?
No, I figured it out.
You got it up? Okay. All right, we've got a few more to go here. What's the opportunity cost of the 16th beer? The opportunity cost of the 16th beer. Now I've got you on the bubble.
1 over 16.
16. Ooh, we got 3, 4. I got you on a bubble one here. Still 1/4. Still 1/4. Why? Because still in the interval. Good, right? So you go back to that's why it's important to tell yourself the story. If I'm looking at the 16th beer, how many do I have already? 15. So I'm clearly going from here to here. I'm still in this interval, right? So the 16th beer is still at that interval, which means that would leave us with a 4. So it's the same. We're just approximating that for those numbers. Okay, and then let's kind of finish up this all the way here. Let me go the 19th beer. The 19th beer is 1/3 of a pizza. And then finally the 20th. So the 19th was in here. And now finally the 20th. Opportunity cost of the 20th? 1. We got one full pizza. All right. So, I always like to kind of reconcile your graphing goggles with your schedule goggles. And so, you know, this one's a little bit crazy here. If you were to say, where does the fifth of a pizza live graphically? We kind of talked about where the ninth one is, but now we've got a fifth of a pizza. I want to reconcile that with this graph. Anybody willing to come to the board for an extra credit point to try to tell me where the fifth of the pizza lives for the ninth beer? The ninth beer is 1/5 of a pizza. Remember that whole thing with the equation goggles, schedule goggles? You can go back and forth. You're just viewing math differently. So I kind of want to reconcile that. So I Ashley's hand up first. Okay, can you be more specific? Are you good? Yeah. I want the fifth. Like, I want to be drilled down to the fifth. Where does the fifth of the pizza live? Like, where? Yeah, so the ninth beer, the opportunity cost of the ninth pizza is a fifth of a pizza. Okay? All right. Can you add any more detail? I want to see where the fifth. Where does the fifth of the pizza live? Where does the fifth of the pizza live? All right, grab a seat. Thank you for playing our game. It was nice. Let me go to the back. You are out now. I saw your hands back. Come on up. Yeah, Ashley's on to something there. Just wasn't quite where I wanted it to be.
Yeah.
Okay. Ooh, I like that. That section. What is that section? It's a fifth of pizza. Good. So that's what I wanted to do is make. Thank you. What's your name? Dylan. Dylan Wheeler. All right. And Ashley, we're going to give you 1, 2 for playing our game today. Dylan, what was your last name again? Wheeler with the W. Okay. Last one. All right. So, now I like what Ashley did with drawing a straight line. So remember, Tom and Jen had a straight line production possibilities frontier. What's the slope of that line segment? Careful. What's the slope of that? -5, right? Rise over run. You're going to do that with some of your homework and test questions here. Down 5 over 1. So the slope of that is -5. Rise over run, down 5 over 1, right? And that has an interesting relationship over here. What's it equal to? The 5, the slope. The slope is 5. What's that related to on this whole business that we spent time doing?
Fourth pizza.
Yeah, the fourth pizza, right? So the opportunity cost is equal to the slope. There's a connection here between the slope of the production possibilities frontier and the opportunity cost of each good. I'll write that out later in general what that is, but I wanted to point it out now. That we're always giving up 5, giving 1, which then leads us to this fifth business. Well, I'm just going to total eyeball here. 1, 2, 3, 4, 5. Yeah, perfect. So if this was 1, 2, 3, this is 3 and 3/5. This number is 3 and 4/5, right? 3 and 5/5 would be 4. Right? So we just broke that sucker down into 5 segments. And so Dylan correctly identified that this little section here is where our little fifth of a pizza lives. 1 pizza, 2 pizza, 3 pizza, 3 and 3/5 pizza, 3 and 4/5 pizza. That slice lives right on the horizontal axis. The problem I had with Ashley's point is that she was up in 2-dimensional space, right? There was actually 2 things defining that. We had the amount of pizza, the amount of beer and the amount of pizza in the 2-dimensional space. which is good in different respects. I like that too, because I want you guys to remember when we are doing these functions or these curves, some will be curves, some will be lines. Whenever you're out in this world, there's two things that you should be thinking about, unless we're doing a three-dimensional graph, which will do a little tiny bit, but otherwise we'll be in 2 dimensions, and those dimensions are defined by the vertical and horizontal axis. So that space out here has a certain amount of beers associated with it, and a certain amount of pizzas associated with it. There's more data, more information possessed out in this graphing space. All right, so if we did the same thing, we start to get that bowed out look. There's really a straight line connecting all of these. And so if you guys want to on your graph, you can kind of get this bowed out look for the production possibilities frontier. Well, where does that come from? Well, let's look at what's happening to the cost. What's happening to the opportunity cost of pizza as we acquire more and more of it? Is the cost going up or down? Up. The first one was pretty cheap. Last one was pretty expensive. Now, what's going on with beer? Is it just the opposite? Is it getting smaller or is it going up? Got those fractions, that always makes it a little tougher. It's going up too, right? Don't let the fractions fool you. We got 20%, 0.2, right? 0.2, 0.25, 0.33, 1. So those numbers are going up as well. So the cost of each additional unit is increasing as we produce more and more of it. And you might be saying, well, why? That's not real world, Russ. Everybody knows that if you buy 2 pizzas, sometimes you'll get 2 for the price of 1, or the second one will be half price. It gets cheaper as you buy more. Don't you go to Sam's Club? Don't you buy a big gallon jug of ketchup when you go to Sam's Club for, $10? Everything's $10 at Sam's Club. Everything's cheaper when you buy more of it. Well, that's true for different reasons that we'll get into later. This question here is a little bit different because we're looking at economy-wide, right? The production. And as we produce more and more pizza, imagine us trucking along this line from point A to B to C to D to E to F, right? We're kind of changing. As we go here, we're starting to take resources and we're slamming them all into pizza production. Taking what used to be a big, how many of you have been to a brewery, right? You've seen the big vats of beer where they brew everything, right? Well, as we get down to point F, those big kettles are being used for tomato sauce or something, right? They were really meant for brewing beer. They're kind of a specialized machine for brewing beer. But since we're not making any more beer, we're being forced to using that big kettle into pizza production. We're forcing brewers who are really good at making some good beers. They know the hops, they know the chemistry, they know everything. We're taking those people and having them toss pizzas. It doesn't make sense. It's kind of like sending Jen out to harvest coconuts or Tom to go fishing, right? So as we start to slam resources into things that they weren't really made for or aren't really good at, it becomes more costly. As we get more and more pizzas, you're giving up more and more beer each time. Because some resources are better suited for the production of some goods rather than others. And that's where this bowed out of production possibilities frontier comes from. Now the flip side of that is if I'm at point F, how costly are those first few beers? They're pretty cheap. All of a sudden I'm getting the tomato sauce out of the expensive machinery we had, and I'm taking my brewer who was tossing pizzas, and he's going to go make some beer. He can do it really cheap because the resources are all there. They're plentiful, right? And so, boom, we can make those first beers really cheap. But again, as we start to move from F to E to D to C to B, we start to be slamming all resources into beer production. Now we're coming up with tomato beer or something crazy. We're kind of putting things that were meant for pizza production, the pizza ovens and the people who are best at making pizza, we're slamming them into beer production, something that they weren't really meant for. We can do it, but it's very costly to do it. Costly in terms of what? Costly in terms of the pizza that I'm giving up to do it, right? That's opportunity cost. That's the law of increasing costs. The law of increasing opportunity cost. We don't have dollars or anything going on here. We're taking an existing resource base. What are the resources again? Land, capital, labor, entrepreneurship, right? We make choices of what that goes to. At any given point in time, we can add up all of the resources at our disposal. Like right now, if we could freeze time, we could take an inventory of all the resources. Production possibility would be to make all beer. That would be one possibility. But it's going to be real cheap for us to make some of both goods. Okay, questions or comments on that? All right, so let me write out a little bit of that with the increasing costs here and some other things. So why is this is a great test question here, why is the production possibility frontier, whoops, I put the question too soon, bowed outward? Why is the production possibilities frontier bowed out? Answer, some resources are better suited for the production of one good or another. Some resources are better suited for the production of one good or the other. Why do opportunity costs increase as more is produced? Question mark. Same answer. Same answer is up here. This is in part due to the law of increasing costs. And we'll come back to that in future chapters as well and put a little more meat on the bones back. Okay, so a couple more comments on this graph. One is that the real production possibilities frontier would be a curve. So the real one, I don't know if you guys want to, I'll just write this as a separate note so that we don't mucky up that graph anymore. So note, the real PPF is a curve. In other words, it would look like this. Not these line segments as Ashley did here. Straight line, straight line, straight line, and it starts to give us the idea. That was just because we didn't have enough information, right? We didn't have enough information here. If we had enough data, there'd be this kind of continuous relationship between the trade-offs of the resources and the production of the two goods. Let me put, just change things up a little bit, the quantity of ramen and the quantity of shoes. Same thing. Maybe we can figure out a way to make noodle shoes, but it's gonna be expensive in terms of the amount of ramen that we're giving up if we do it. All right, so what's your name again?
Erasmo.
Huh?
Erasmo.
Erasmo. Did I say that right?
Yeah.
Okay. Erasmo asked me, what is this for? We haven't really got to it. Now the macro students know what this is for. This is just one little illustration. It's kind of a multi-purpose thing. Like if there's talking going on, excessive talking or whatever. So it kind of makes a decent weapon. I'm not gonna lie, but that's not the primary purpose. The main thing is to do stuff like slopes. How do we calculate the slope? Remember the slope was 5, and that was related to the slope of the line segment that Ashley did? And we also did Tom and Jen, where it was all over the whole thing, and it was 2 fish for one coconut, and that was the slope of the consumption possibilities frontier, right? So we got the whole rise of the run. That's true when we have lines. What happens when we have a curve? How do we find the slope of a curve? The tangent line, good, right? Remember that thing, the tangent line? That's this. So there is no straight line in this curve kind of by definition. And so if I look at point A versus point B, the way that we calculate the slope is we take kind of an infinite rise over run, if you will, an infinite rise over run by taking a line and moving it and dropping it down until it's just kissing, right there, just kissing that single point, right? There's one point only where the line segment will just kiss it. If we put it right at point A, and we calculate now the rise over the run of this line segment, that's the slope of the production possibilities frontier at that point. Right? So the slope of the tangent line is now the slope of the production possibilities frontier when it's a curve. Now, at point B, did shoes become more expensive or less expensive? Now I'm really pushing you here, right? More, right? As we start to do this, we're slamming resources that are better suited for ramen into shoe production, so they become more costly. What happens to the slope? We drop our tangent line in, and I can't make a good kissing noise. Just kissing right there. What's true of the slope? Is it bigger or smaller in terms of absolute value? I hate to throw that out to you, but it's bigger, right? We got the negative thing and negative 10, so that kind of screws it up. But it's bigger. In terms of the slope of the rise over the run, you're giving up a lot more ramen to get an extra shoe, right? So that's our connection with the curves when we get to a curved production possibilities frontier. All right, so the real production possibilities frontier is a curve. If we take the tangent line, the slope of the tangent line is the slope of the curve of the PPF at that point. And I'm writing kind of small there, but the slope of the tangent line is the slope of the production possibilities frontier at that point A. So it's specific to point A. Because as we just said, the slope of the tangent line at point B is different. It's steeper. The cost is more. So this is steeper. And that connects in with that connects to our business with opportunity cost, kind of tie these things together. All right, so special note to kind of memorize will help you with some of your homework problems and give you kind of a shortcut. I like to give students as many shortcuts as I can. So note the opportunity cost of whatever you're measuring on the horizontal axis. Let's all write that out first. The opportunity cost of whatever is measured on the horizontal axis the opportunity cost of whatever is measured on the horizontal axis is equal to the slope of the PPF. That's the shortcut. So if you hopefully get more comfortable with the rise over the run business and you're able to calculate a slope, whether it's the slope of the curve or the slope of a point or the slope of a line, the opportunity cost of whatever you're measuring on the horizontal axis is equal to that slope. Now, I don't even like to put this in, but some of you math geeks out there, I know who you are, you're kind of puckering up right now. Well, technically, Dr. McCullough, the slope here is negative and the opportunity cost is positive. And you're absolutely right. Okay, so I'm just going to let that one go because normal people don't think that way. And I like to teach this to the normal folks here. So it is true. Remember that if I ask for the slope, and you might say I'm not being fair then on the test, but this is being recorded so that this caveat's on here. The slope is indeed negative. And so if I ask you for the slope, the correct answer is -5, I guess in this case, right? You got the -5 there. The opportunity cost of pizza, whatever was measured on the horizontal axis, was equal to 5 beers, right? So that was still flowing, but technically it's, the opportunity cost is a positive and the slope is negative. Okay. Questions or comments there? By the way, I don't actually know who you are, the math geek. I said that. Sometimes things come out of my mouth just in the heat of the moment. And I just want to let you know I'm not targeting any one of you. I don't know who you are, but you know who you are is what I'm actually. Okay. Let's see. So if we were to map out the marginal cost, what would that look like? So the next thing I want to bring in is this idea of marginal cost. Marginal cost. This is related to opportunity cost. But it's simply the cost of an additional unit. Just to keep it real simple, the cost of an additional unit. And we're going to draw a new graph with, I guess we'll use our pizza. 1, 2, 3, 4, 5. That's probably the easiest thing to do. 1, 2, 3, 4, 5. I am measuring beer up here, but don't worry about putting any hash marks because I want to graph out the marginal cost of pizza in terms of beer. So what was the marginal cost of the first pizza? What was the marginal cost of the first pizza? 1. So the first pizza we got for a beer. So there was 1, let's see, 1. 1 for 1. What was the cost of the second pizza? 3. Okay. So now we're going to go 1, 2, 3. And plot that point. The cost of the third pizza was 4. All right, so now we're just mapping out exactly what I gave you in the other graph, or the other thing that we wrote out, so you can kind of look there. The cost of the fourth was 5. So literally the fourth pizza cost me 5 beers. And then finally the fifth was pretty expensive here at 7. So this line is related to this one. And if we connect, go ahead and just connect the dots. It doesn't matter if it's a straight line because it's actually not a straight line. This is the marginal cost line by analyzing each additional unit, the cost of each additional unit. so this is not a pair of goggles that I normally do on the front end, but this is I invented this set of goggles later, so it doesn't really belong with the first set. So this is like an addendum to my goggle theory. And the addendum is this. When you look at a graph, it has a marginal curve in it of some sort. We're going to do lots of marginal curves, but whenever you see the M word over here, the set of goggles that I want you to put on is called, I call the suffix goggles. The suffix goggles. I don't even know if I'm really being proper with what I'm calling it, but so the suffix that's being put on here is that the textbook's going to show a 1, but if you're looking at this curve, I want you to put the little st in front of it. On my econ lab, it's going to show a 2 here, but I want you to have your suffix goggles on and put the little in there. And the erd. And the, right? So whenever we look at a curve that's a marginal curve, then put your suffix goggles on. This, again, will not be in the textbook, but you will understand this stuff so much better if you get that down, the suffix part. Because that's the interpretation that we're having, which is exactly what we did when we wrote it out, right? The opportunity cost of the third pizza was 4 beers. And now it kind of makes sense. All right, questions there? All right, all of this talk has been about the cost and production. But where are we going to be? Just as equally interesting, if not more interesting, is where are we going to be? Are we going to be at point A, B, C, D, E, or F? As an economy, we have to choose one, right? These are production possibilities, but somehow we have to choose. Should I be at C? Should I be at D? Should I be at E? Should I be at F? What drives that choice? Efficiency of what? Production? We kind of have that all on here. What did we call this on Wednesday? Points A, B, C, and D, E, and F were all equally efficient of what kind? Look back in your notes if you don't remember. This is one you're going to need to know. Production efficiency. Good. So all of those points are equally productively efficient. In other words, D is no better than E. E is no better than F. They're all equally efficient production points. And so what did we talk about being inside the frontier? Inefficient, right? And the idea was, our definition of efficiency that I gave you was that if you're at a point like E, F, G, if you're at G, it's possible for you to have more pizza to go to D without giving up any beer. That's a pretty good deal. That's like a free lunch, right? It's possible for you to go up to C. It's possible to go in between. You can have more without having any additional resources. So point G, you were being inefficient. You either didn't use up all the resources that you could have, or you just sucked at what you did. You didn't use the right technology, right? Because if we think about the blueprint of how we could do this, you sucked at that. You weren't good at figuring it out, right? So you were stuck at point G. Okay, so all of these are equally productively efficient. Which one do we get? What drives that answer? Riley? Okay, depends on who you trade with. Yeah, that's part of it. Add on to that. So we're bringing in the trade aspect into it. Demand, good. That's another word that we're not quite ready to graduate to, because that's next week's material. We'll get into supply and demand. But demand type things. What's true about, talk to me about demand. What does it mean to demand something? You need to have it, you want to have it, right? Why are you demanding it in the first place? What does it bring you? Joy, pleasure, happiness, whatever we call it. You want it because it's going to make you feel better or get you more happiness. That part is totally absent here on what we've done. We have exclusively focused in on production or on the supply of the good. So the preferences of the consumers who are ultimately going to use this stuff has been ignored at this point. And so the answer of whether we're going to be at B or E probably depends on, are we beer people or are we pizza people? Right? Do we have an alcohol or do we not? Do I like to eat more than I like to drink? Right? That's our preferences. That's on the consumer side. So what's going to drive the answer of where we are depends on the benefits that we get from the good. The benefits, which we haven't talked about yet, but it's talked about in your chapter 2 stuff. Now talk to me about these benefits. Talk to me in terms of the first slice of pizza, the second slice, the third slice, the fourth, the fifth. How many people can eat 5 slices of pizza in one setting? Look at all these athletes in here. Yeah, give me 10. I'll eat the whole damn thing. I don't care. All right? But, so, talk to me about, you're really hungry, right? You've been traveling on the road. You've been gone. You're going to go out for pizza that night to your favorite pizza place. Talk to me about the value of that first. Is that close to heaven when you're really hungry and you're just dying, right? That's right up there. Now, how does the second slice compare to the first? Good, but not as good. It's hard to describe that first bite, right? If we went bite by bite, we could actually analyze this deeper. So as we progress into the third, the fourth, the fifth, how does the fifth slice compare to the second? Yeah, it's starting to get painful. Maybe starting to get to the point for most of us on, oh, I really shouldn't eat this slice, but I really want it. It tastes good on my taste buds, but I know my little tummy's going to get a little bigger if I eat another one, right? So you start analyzing how much benefit am I actually getting? And this is so appropriate when we go to the pizza buffet, right? Because what's true about the cost of each additional slice of pizza? Monetary cost is nothing, right? So we're totally driven by the marginal benefit when we go to the pizza buffet. We will keep consuming until the marginal benefit of the last slice is what? We're not worried about cost. 0. If I get 0.01 units of happiness and it costs me nothing for that last slice, go eat that last slice, right? So we're going to drive those benefits to 0. So if we come back up here to this graph, and we're going to actually spend time on this in a different chapter. So right now it's just to kind of motivate where we end up, because I don't want to leave you with just production. And we actually mapped out the benefit. The first pizza, hey, it's heaven. The second slice, it's good, but it's not quite as good as heaven, right? The third slice, something less. The slice, something less. The fifth slice. The sixth brings us to maybe the toilet or something. I don't know. We need a bathroom break. We're going to drive that sucker all the way down to 0. And so the marginal benefit curve looks something like that. The benefit that we derive from consumption ends up diminishing, going down. The benefit that we get from each additional slice. Remember that we would have never eaten 3 slices if the total benefit wasn't going up, right? So I'm still getting happier. It's just that the marginal benefit, the extra benefit that I get from each one is going down. I'm still getting happier, but my rate of increase of my happiness is getting less and less, right? The rate of change. Those of you who had a little calculus here, where we're talking about that second derivative being negative as we're going up the mountain. All right. So picture how many slices we should eat if we're operating efficiently. 3. We're going to keep consuming until the benefit of the last unit consumed is equal to the cost of the last unit. And so on this graph, the way I've told the picture here with this marginal benefit curve, this ends up being the optimal Q star for pizza, and this is the optimal beer star, what economists would probably call equilibrium, right? Our equilibrium quantity of beer and pizza would be at 3 and 4. I'm sorry, 3 pizzas. It's 4 is that the margin is the cost. So on this graph, we're at 3 and 12. We're going to be at this point. All of these are equally productively efficient. This point is allocatively efficient. Allocatively efficient. If marginal benefit equals marginal cost at that point. That's a huge condition because I don't want you to get screwed up with all of these points, remember, are productively efficient. But that point right there ends up being the happy point. Let you write that out here. That's basically the definition of allocative efficiency. So where consumption is such that the marginal benefit equals marginal cost, that's allocative efficiency. Allocative efficiency. So we got 2 forms of efficiency going on. We had production efficiency, which was the fact that we were on the curve, not inside the curve. On the curve somewhere, but not inside the curve, production efficiency. If we're on the curve and it's where marginal benefit equals marginal cost, we've got happy campers. We're also allocatively efficient. So graphically, check out what goes on over here if we go too far or too little. If we are at 4, the marginal cost of the 4th pizza is greater than the benefit. That was stupid, right? And so we have what economists call a deadweight loss that we'll talk about later. You don't even have to write that down right now. But it's inefficient. It's inefficient. In terms of allocative efficiency, you're not there because you've got too much consumption, too much pizza is being consumed relative to the benefit of pizza. And likewise down here, if we're at 2, it's great that the benefit of that slice is greater than the cost, but you're leaving a little happiness on the table relative to your budget. Because if you consume a little more, now the benefit, if we did this in increments on 2.5 pizzas, right, there's still benefit coming in and it's greater than the cost. And so right here is where we have that allocative efficiency. Okay, questions or comments there? All right. Whew. All right. That wraps up chapter 2. We're going to start to get into chapter 3 today. So we're going to get a jump on chapter 3. So that is all you need. If you want to draw a line in your notes, you can say that this is module 1 stuff. Kind of stops with this. All right, and this is a perfect setup. A perfect setup for the start of the next material. And that is going to be on supply and demand. And we're going to start with demand. So this just kind of set the table for the demand curve. All right. So I think it's always important to lay down the law for starters. If we burn through the juice. They got a backup here. All right. So the first thing we're going to look at is the law of demand. So this is chapter 3 material. So chapter 3. Chapter 3, supply and demand. We're going to start with the law of demand. So law of demand is as Hansi? 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 Oh, hey! How you doing? What's going on?
Yeah, my sister will ask me something.
Ah, yeah, tell your sister to get out of here. You're at class, remember?
Okay, I will
remember?
tell her to get out here.
Yeah,
Sorry.
that's the way it works. It's like you're really in this classroom, believe it or not. Yes. All right, good deal. So, as the law of demand, as the price of a good, as the price of a good increases, the quantity demanded, which we're going to use the kind of short symbol here, QD, quantity demanded. P will just be price, like we've been doing. As the price of a good increases, the quantity demanded does what? Decreases, right? So if things get more expensive, the quantity demanded decreases. As the price of a good increases, the quantity demanded decreases. Now, does everybody agree with that? Not necessarily. Give me some examples. What's that? The iPhone. What about it?
Everybody wants one, but every year, like the 7's going out, and it's supposed to be over $1,000.
Okay, so the price of it went up, and they still sold more of them. Maybe some record sales or something. We don't have exact data, but that's what you're saying, right?
It's not out yet.
Okay, so that's cool. No, that's what I want. What else? Give me some other examples.
Gas.
Gas, how so?
Up till the not good enough to go, so they're doing $5 price.
Okay, so gas might start to get to the point where it doesn't matter if it goes up, I'm still going to drive. I might even drive more if I have to for my job. Maybe I got a new job in sales or something, so I'm gonna drive more. Okay, good. What else? Yeah.
Maybe like.
Okay, good. So yeah, sports team starts doing better. They jack up the prices on you at the gate. Great example. Pharmaceuticals. Okay, so same thing. People might need the drug. Is that what you're thinking of? Okay, good. What else? Other examples. There's actually lots of ways to punch holes in this.
Cigarettes.
Cigarettes. What about cigarettes?
Still buying.
People still buying them. They jack up the price. So I was shocked. Since you brought up cigarettes, I went to India with this online student. I did a student trip to India just a month ago, and he lived in Chicago. $15 a pack, because the tax is basically $10 a pack. So and that's within the Chicago city limits. It's not statewide. I don't think it's statewide. No, I don't think it was statewide, but $15 a pack. So yeah, but people are still smoking. Maybe a couple people cut back, but there's some people that you wouldn't think that they'd actually do more on that case, but maybe.
In Canada compared to here,
Here
it's like $2 and something a tin of like chewing tobacco, and there it's $25.
Canada's got the tax jacked up, as you got, it looks like a chew in your lips, so you're enjoying the American prices. Is that what induced you to go higher? Yeah.
Statewide tax in Alaska, those cigarettes
Are how much?
over $10.
Over $10 up there too. Okay, and we're going to talk about taxes. That's not next week, but the week after. We'll get into taxes. So you guys did a great job of punching holes in this, and then that means as a law, it kind of sucks, doesn't it? I thought this was the law of demand, and you guys just gave me, some great examples where this isn't true. That doesn't sound like much of a law, and the reason is because I lied to you at this point. This is not the right definition of the law of demand. It's missing something. It's actually missing the most important piece of the whole definition of the law is missing on this. And what's missing is a Latin phrase, Ceteris Paribus. Ceteris Paribus. If anybody's had Latin, I think I've heard it, Ceteris might be the right way to do it. But you're shaking your head, you got Latin? Is that, how would you pronounce it?
You had it right, but Ceteris.
Ceteris?
Yes.
And is it Paribus or anything, or is it Paribus? Okay. So Ceteris Paribus. I was probably still going to say Ceteris, but that's right. So what does that mean? All other things held constant. All other things held constant. All other things held constant. So for the iPhone, we're not going to let it have new bells and whistles to it, right? The quality of the iPhone has to be the same. The time frame has to be the same, even if it was something in the future that was forthcoming. We have the gasoline, right? So we're going to hold all other factors constant. You didn't get a new job that required more driving, right? You didn't have more income. So nothing else is allowed to change. If that's true, the law is you make it more expensive, you're going to sell less of it. People aren't going to want as much of it. Some people might not change their behavior. But remember, we're not necessarily applying this just to an individual. So the individual who does not buy less gas because the price went up, what do some people do who are more price sensitive, that are on a really tight budget? If gasoline prices jump, what might they do to get to work? Bus, bike, walk, carpool. All those things start happening, right? Not to everybody, but as long as one person decides to carpool, we have the law of demand intact, right? Price went up, somebody cut back. Somebody cut back. That's the law of demand. An inverse relationship between price and quantity demanded. An inverse relationship, or a negative relationship, those of you who got through your math quiz, I'll be, by the way, talking to those who don't. I'll look for my email on those who did not get their 70% on the math quiz at this point. I'll be sending out an email later today. But the negative or inverse relationship means as the price went up, quantity demanded went down, which also means, though, if price goes down, quantity demanded goes up. So remember, it goes both directions. So sometimes when we write this definition, we might do that as the price of a good increases, parentheses, decreases, the quantity demanded decreases, parentheses, increases, because it works both directions, right? It's an inverse relationship or a negative relationship between these two variables, quantity demanded and price. All right, so let's do a little more graphing today. I think would be a good spot to go. So note the demand curve, which we haven't actually defined yet, is a little different than this law of demand. It's related, but it's different. The demand curve shows, demand curve D, which I'll define in a sec, shows an inverse or negative relation between price and quantity demanded. Which means an increase in price leads to a decrease in quantity demanded, or a decrease in price leads to an increase in quantity demanded. Make it cheaper, people buy more, holding all other things constant. If we graph out that relationship between price and quantity, how is that negative relationship going to manifest itself graphically? How is that inverse relationship going to manifest itself graphically? A line going A, B, or C? C, right? So this is the demand curve. which we'll be kind of just noting with a capital D, demand curve, that's our choice. This function shows a negative relationship. This is all in your math appendix if you guys need to review that again. A shows a positive relationship, right, between quantity and price. Guess what that's going to be later? The supply curve, you got it. And we saw it with the marginal cost curve too, but that's going to be supply is a positive relationship between the two. And B means that there's no relationship between price and quantity. Turns out this could be either one of them. That's kind of a hybrid case. This is, let me just put on at this point, this is a crazy, not so crazy really, crazy hybrid case. So we got that kind of fun going for us here. That'll be coming up later. All right, so let's do a little more graphing with some specifics. Let's put our so example. Let's look at the beer market in Ottawa. Ottawa, Kansas, not Ottawa, Canada, for my Canadian students. But you could probably make it out of Canada. I assume you just have to increase the quantity demanded right there. So let's say that if the price of beer and quantity beer, we're going to throw our schedule goggles on right now. If the price of beer is 12 bucks, we're going to sell 160 cases. Maybe these are 12 packs. Maybe these are 6 packs. Inflation is going on. When I started teaching this 20 years ago, that was the case. Now, okay. So we got a 6-pack of beer at $12. If that price falls to 10, let's say we sell 40 more, it goes up to 200. At $8, we sell 240. At $6, we sell 280. At $4, we sell 320. So once again, let's graph this out. What does this relationship look like? So you can just kind of go, try to keep spaces relatively even. It doesn't matter too much with this one, especially since the quantities are weird. But you know, you can go 2, 4, 6, 8, and 12. So this is the price on the vertical axis. We're measuring beer on the quantity axis. And so we got kind of one of those little squiggle marks right here. And then we'll do 160, 200, 240, 280, finally 320. All right, so go ahead and plot those points, similar to what we did with the production possibilities frontier, but now we're making the demand curve. What's that? If you draw it real carefully, it's going to be straight. Yeah, I know some of you guys would have been like, you know about my cell phone rule? Like, totally off, not vibrate. I was measuring your phone during class. Or out. Make sure you get A couple of you guys came on Wednesday night.
Oh.
51.
All right, so we got our demand curves. So 160, 12, 10, 200, and as Tyler, right? You had Ty or Tyler? I can't remember. Ty. As Ty was asking, if you draw it really carefully, this slope is the same all the way down, right? The rise over the run. So it should be a straight line.
Yeah.
And that would be your demand curve. All right. So let's add some supply action in here. So this is the quantity demanded of beer. Quantity demanded. And now let's look at the quantity of beer supplied. Now, before we go there, let's think about the behavior of producers. If you are a seller of beer at the Blue Sky Liquor down here, or Brandywine in Ottawa, do you like high prices or low prices? Yeah, if you're a seller of it. You like high prices, right? I mean, you want, if there's a, yeah, if they're selling, you don't want stuff to be sitting on your shelves. We'll kind of come back to that. But holding all other things constant, ceteris paribus, would you prefer to be having a higher sale price or a lower sale price? Higher, right? Definitely higher. More price, more profit. And so we've got the law of supply. We've got the law of demand and the law of supply. As the price of a good increases, the quantity supplied, the quantity supplied decreases. Decreases or increases? As the price of a good increases, the quantity supplied increases. Positive relationship. Quantity supplied increases. Ceteris paribus. Holding all other things constant. Like the cost of the good, for instance. Yeah, using one to hold it constant. Okay, so that's our law of supply. Very similar, opposite direction. So let's go back to our little graph here. And say that the quantity supplied by the liquor store, at a price of $12, they're willing to supply 320. At a price of $10, they're willing to supply 280. At a price of $8, they're willing to supply 240. At a price of $6, 200. And finally, at a price of $4, 160. And then go ahead and graph that out. So basically just ran the numbers in reverse order. 320, 280, 240, 200, 160. And then graph that thing out.
That's the price?
Huh?
That's the price?
No, this is the quantity supplied. I use the same price schedule.
Yeah, that's what I mean. Right?
So at these prices, this is the quantity demanded, this is the quantity supplied. Okay? Okay, looks good, looks good. All right, so then you can kind of connect those dots if you want and put a big S on there because that's our supply curve. Okay. So, guess where equilibrium is? Right in the middle, where the two lines cross. All the exciting things in econ class tend to happen, not quite 100% of them, but a lot of them happen where the two lines cross. So something special's going on there. What's going on in terms of this schedule of numbers if we look at it that way? Where the two lines cross, what's happening with quantity demanded, the amount people want to buy, and the quantity supplied by the business, the amount that they're putting on the shelves. They're equal, right? So that's what gives us this what we call equilibrium. Is that so? If you have some problems, remember, will just have your schedule values that you're doing on your homework stuff. And so the way you find equilibrium is to look at where the two numbers are equal, right? So right here at 240, we have the quantity demanded equal to the quantity supplied at the price of $8. Graphically, at $8, the quantity demanded, go to the demand curve, drop down is 240, the quantity demanded is 240. The supply curve, I go over to the supply curve, happens to be the same spot, drop down, the quantity supplied is 240. All right, so sometimes it's kind of like we want to figure out, well, why would we expect it to go there? How does that happen? So I want to bring us back to human behavior. Economics is a lot about the study of behavior of people under circumstances of scarcity. And so imagine that the price of beer was $12, just hypothetically speaking. Suppose that the price of beer was $12. Of course, we already said that the producer likes having high prices, so why not? Jack it up to 12, what the heck? High prices are better, let's do it. What is the outcome in the market if there is a price of $12? A surplus, right? So there's extra beer is kind of the way to look at it. At a price of $12, the quantity supplied is greater than the quantity demanded, and so we are supplying 320. There's 320 units being supplied, and only 160 are being purchased, leaving how many on the shelves? Just keeping up with me. I know these are getting into some big numbers, but what is our surplus exactly? How many sticks are left on the shelf? 160, right? 320 minus 160. Visually, it's the horizontal distance between the supply curve and the demand curve ends up being equal to the surplus of 160 six-packs. That's what's left on the table. What do businesses do when they have excess inventory? They have a sale, right? So the extra beer left on the shelves was a signal to the businesses that says, hey, your price is too high. They're like, hey, I'm no dummy. I'm going to drop the price. Tomorrow we have a sale, $8 off. What happens tomorrow when Blue Sky Liquor drops their prices to $4? Do they sell out? Yeah. Tell me a little bit more detail on that. Suppose that they open up at 10 a.m. and they close down at 10 p.m. That's the hours of their business. 10 a.m. to 10 p.m. What happens throughout the day? How does this actually transpire that they run out? When do they run out? Middle of the day, maybe? Yeah. Middle of the night? What'd you say?
Depends on people's section. Probably.
Did anybody go to Price Chopper yesterday between 4 and 10?
I did.
What time did you guys go?
For us. 6.
6? What was it like? Was there still people parked all over? I went at 4. 4:15 by the time I got there. I think I left here. And it was freaking unbelievable. No shopping carts, no baskets.
I didn't even find it.
I know, because I was trying to get in there, and I had another thing I needed to get to, and they had 96-cent grapes and 96 cents a pound chicken, and so I just wanted to gather some of that stuff. It was a 6-hour sale from 4 to 10. And I drove up there, I'm like, you gotta be kidding me, there's people parked in the grass. You would have thought that, you know, some celebrity was in town or something. So it was absolutely a zoo. And what they might have learned is that they had this going on. I guarantee they had to have run out of stuff. Did they have everything? Did you guys buy some stuff on sale? Did you guys buy stuff? You said you didn't, but what did you buy? Of the super duper deal, yeah, like the grapes and stuff. So there was still enough on the shelf. The pizzas were gone. Aha! Pizzas were gone. Now they'll usually give you Price Chopper when you have a sale. Their policy, company policy, is they don't want to take people off. That hey, I got here during your 6-hour period and it's gone. It's not like too bad, too sad. You can usually get a rain check. I don't know if you do that, but you probably could have got a rain check for your pizzas. So remember that, I guess, if this ever comes up again. But this was unbelievable. I couldn't believe how many people were there. So let's say in our liquor store thing, they don't do the rain check business. They drop the price of the 6-packs to 4. They open their doors at 10. They're sold out by noon, right? That's like dirt cheap. I'm going to stock up, and they're sold out. All right, so first of all, what do you think the beer sale guy is going to do? What do you think the guy who owns the business is going to do tomorrow? Bring more beer or raise the price? Oops, I screwed up. We were a little too cheap on that. 96-cent grapes was such, and 96 cents a pound chicken. And then there was whatever your pizzas were. I mean, there was some really, really good deals there. So that stuff was a little too cheap. Now, that is on the supply side, but let me go to the consumer behavior. Let's go to the consumer behavior. So suppose this is on a Friday, and you're having a party tonight. And being the good student that you are, you've got economics course, and then you've got something else to be at. There's no way you could get to the liquor store before 5 p.m. There's no way that you could get to the liquor store before 5 p.m. Everybody's counting on you to bring home the beer tonight, right? It's Friday night, it's party night. So, knowing that they've got this cheap beer, and knowing that they normally sell out by noon, what might you do? What might the clever consumer do? And one of those answers is not skip class and get there early. What might be some other thing? And that might happen, right? It might force you to do that stuff. What's some things you could do? Okay, how?
Call in.
All right, now when you call in and they say, I'm sorry, sir, we don't take reservations for beer at $4. What? We're kind of leading you a little bit here. I'm sorry, sir, we don't carry.
You're going to pay $6.
Ah, now you got it, right? Hey, man, I got this party night. I got to get it. I tell you what, I'll pay you $6. I'll pay you $8. But you got to hold back 10, 10 of those babies for me, right? So what I'm saying is that in the marketplace, both on the consumer side as well as the producer side, both have incentive to see prices rise. Now, some consumers who got there before noon, they're totally happy, of course, they bought the $4 beer. But it's these 160 folks that are really ticked off. And they have incentive to raise the price too. So whether we're in the face of a surplus or a shortage, so down here we have what we're going to call a shortage of 160. There's going to be market forces that are going to try to bring the price down. Let me go back up to the surplus situation. Is there potential incentive or pressure, market forces on the consumer side when The liquor store has 160 cases. They're sitting fat on inventory. What might the savvy personal finance Dave Ramsey buyer do when they walk in and they see, man, this guy's got so much. I bet he'd love to unload this. Make a deal, right? So now the consumer comes in and says, hey, I know you got this problem, but I tell you what, I'll take 10 of those babies off your hands. But man, you got to cut me something. How about we do it at 8 or 10 or whatever, right? And so there's market forces on both sides, what Adam Smith called the invisible hand of the marketplace, that's going to push prices towards an agreeable level. And we still got a little bit of time here, folks, so hold on. Hold the fort here. I tend to hold late if there's too much packing on going on. I still got at least 10 seconds. They're going to push towards equilibrium, right? So that pricing mechanism is going to push us to where there's no surplus or no shortage, and that's right at our $8. All right, we'll call it a day. Have a good week.
Question?
Yeah, the back
test that we took.
You want to work on that stuff?
Pass fail, or what grade you got?
It's a pass fail if you don't get up to 70%. What did you get?
I got an 8, but
That's okay, so you're fine.
okay, I just didn't know if like
You wanna work on it together?
Yeah.
Well, a couple thoughts. You can still go in and improve your score later. So if you wanted to retake it or something.
I just didn't, yeah, I had like a
This is my man's, bro. Bro, spit some fire right now. Come on.
I just didn't, at those points.
You know, there's still people looking at you, right?
Yeah, it won't hurt you.
They're still on. Oh.
Get those points. On the Micro Lab, you can press.
Oh no, what are you about to do?
Probably gonna
So
go
on,
eat and
we'll
then.
be able to review it.
I was. And I
I'm about to go
already-
get touches.
I'll get
I'm
back
about to
and
go
see
get
that.
touches.
Well, it's a loaded question. Right now, I'm gonna open it again, you can't send that to, you can't review it unless it's open. So I'll get you taken care of either way. So why don't you, go back, if you go back now and you're able to jump in there
What?
and try to email me, because I haven't.
Okay, I need to run after.
Okay.
But then furthermore, if you want to go in and try to get 100 on it or something, you can.
Okay.
You can just report. But yeah, definitely if you got, if there was a wrong answer, we like to report that. Pearson is good about if there's just, their computer program is screwed up.
Yeah, I just don't know if I missed something, but I looked
You
at
might.
it, I looked at it multiple times and
Okay.
it looks the exact same to me.
Yeah, but then I can send it to the publisher if it's messed up.
Well, like, did you take the math test?
2 o'clock. No, I teach.
Yeah, I had one and it told me mine was wrong, but it was like the exact same stuff that they had, so I was confused.
So I did it, and one of my things is I was gonna email you, but it was kind of late.
Okay.
And,
Well, you can always email, I just won't respond.
well, I guess it's too late.
Okay.
And you guys might be able to answer too. Most of the questions I got wrong were on the graphs. I couldn't figure out, and I read like the help section.
Okay.
Thank you, sir. I will see you next
Welcome.
Monday.
Goodbye.
I couldn't figure out how to
Bye. Thank you.
tell you where to label, like for example, the freezing point and boiling point. You count off if you didn't do that.
I did the wrong assignment and it
Oh.